You know, I wanted to go back just real quickly on one of these slides that I think is so interesting to me. I just have to say that's really optimistic to think that you can roll out some grass and plan to drive on that the next day. You really have to be careful about, cognizant of how that, that grass is going to be growing in that system. And like I think we've been emphasizing, the right product for the right place. And there's several different water quality treatment mechanisms active in permeable pavement systems. And some of them you can imagine. Physical filtration is one of them. That's why they can clog. But biological degradation, these things do have microbial populations growing in them that can be effective hydrocarbon removing mechanisms. Vehicle wash off or spray. You know, you saw the picture that Mark had of all that spray coming up off the road, and well, that stuff hits the undercarriage of a vehicle and stuff washes off the vehicle. In an operating permeable pavement system, you would expect less of that. Just a couple of mechanisms that you might not think of. You know, a lot of different contaminants. We focus primarily on hydrocarbons and metals for the pavement systems, but there are others, certainly nutrients to think about. Chloride, you understand there's nothing that treats chloride. There's no treatment for it. You introduce chloride into the environment, we have no treatment mechanism. So reduction, and that's why University of New Hampshire's research has been really interesting in that they think they're reducing their salting application by 50 to 75%. That's the only treatment mechanism for chloride, period. That can be an advantage, and when using these systems, it's important to think about and refining your application of salting, because you may need less. A lot less. All I'm going to say about this slide is, aren't we glad we're not there? So how many people have used the International BMP database to kind of look at the performance of different BMPs for water quality treatment? It's a great resource if you're interested in this stuff, the International BMP database. And the object there is to gather lots of different studies, well, to look at how these studies were done, be able to compare across studies, which is often very difficult. And so it's a great resource. And when I first started looking into water quality treatment and permeable pavement, I thought, oh, I'll go to the International BMP database and look what they have to say. So this is kind of an older slide, but it was interesting. You can see all these different practices down the left column and permeable pavement up top there. Not many studies at this time, but it was interesting to see that in 3 of the categories, total copper, total zinc, and total phosphorus, permeable pavement was one of the best performers. That surprised me. Digging into that a little further, I'm just going to focus on a couple studies. There's quite a few out there, and there's some new data coming online here soon for our region. A really good study was done by Derek Booth and Bratebo with University of Washington. This was some parking stalls in a King County material handling yard. And so rather, industrial site. And they installed a few different types of permeable pavement systems in parking stalls in that yard. You can see there the gravel pave, grass pave, turf stone, again, another one of these grid systems, EcoStone, a permeable paver, and then they had a conventional asphalt control. You can see some notes on the bottom here. The sections were not very deep, 10 centimeters, about 90 to 100% occupancy, so these things were busy. Look across this and see copper, micrograms per liter, lead, zinc, and then motor oil. And that MDL, minimum detection limit, below minimum detection limit, and then that ND, non-detect. I mean, you can see the differences between the conventional asphalt and the permeable systems. So very good performance. And these were dissolved metals. And so looking at copper, for example, less than 1 part per billion, that's great. All the systems performing pretty well. So this was a regional research project that's really, I think, very valuable for us to kind of get a better sense of how these systems are behaving for water quality treatment. Low numbers on the zinc, too. These other studies, one from France, one from Amsterdam area, and one from Texas, and you can look at the numbers on these. This is one of there'll be 3 studies I want to focus on. This is one from Germany with Dirkus. This is a schematic of a parking stall in this 15-year-old supermarket parking lot. Permeable pavers. This is a great study. They looked at lots of different things. Cleaning machinery, all kinds of different aspects of permeable pavement. But this is one of the best studies we have in the world on how these systems behave long-term for water quality treatment. So you can see that sort of the dark section up top, that's the paver, and then the aggregate base in yellow, and then the subgrade there in orange. And we're looking at copper, zinc, and cadmium, and concentrations for copper and zinc up top, and then the cadmium down below. And these are different, now pay attention, these are different units, milligrams per kilogram. This is soil analysis, not water quality analysis. And then your depths. And so this is, again, 15-year-old parking lot. They identified one that was still infiltrating, also showed signs of heavy use and oil. They took off these pavers and then sort of spoonful by spoonful excavated this, this section and analyzed concentrations of these metals. And you can see, in that section, at about 15 centimeters, so what are we talking here? So something like 6 inches or so. Elevated concentrations, and then those numbers as you get below 15 centimeters are essentially background for soil. They're very, very low concentrations. So this is a really interesting study in that it's long-term, fairly heavy use. It's one study we can point to answer that question, maybe not answer, but at least suggest an answer to the question, how do these things look over time? The words you hear often from people, are we going to create Superfund sites under all these pavement systems that we have to do some sort of special cleanup? And this is a really valuable study as far as thinking about that. And the fundamental question is, we've been approaching stormwater from a wastewater perspective. Collect it, convey it, get it off the property, and get it to a central system that then we discharge or do something with it. And it's basically been a wastewater approach. And we are fundamentally changing that approach in a very big way and now going to these distributed approaches, trying to manage water across the entire site. What that means is we're managing water in lower hydraulic and pollutant concentration loads. I mean, we're distributing across the site. And that may be, I think this study points to that the trend we would hope to see in that approach, and that is these systems being able to handle that lower hydraulic and pollutant concentration load adequately in the soils long term, because we are not concentrating lots of water and higher contaminant loads in one place. We're distributing it across the site. Fundamentally different than what we've been doing. So these are the things I think about when I'm driving to work. I don't know about you. Maybe you don't think about this at all. But anyway, we are taking a very different approach to stormwater in the low impact development green stormwater management approach. And these are the kinds of things we need to consider as we're doing that. The last study that I would focus on as far as water quality treatment would be this really interesting study from Pratt & Newman in UK. And they had both a lab study and then an outside sort of larger scale, mesoscale plots where they were applying motor oil to those plots and tracking the effluent concentration. So they were tracking the mass of oil that they applied onto these cells, and then they were looking at the effluent concentrations. Let's look at the graph at the bottom. The line tending up is the mass of oil applied over time, number of days. The horizontal line down at the bottom, tracking along that x-axis, is then your effluent concentration. Bottom line is very close to 100% removal. What was really interesting about this study, at the same time, they're tracking microbial population in the pavement. And it's a little hard to see on this top graph, but basically the microbial population tracked exactly along with the application of oil. So apply oil, microbial population goes up. Time goes on, hydrocarbon concentrations come down, microbial population goes down. Add more oil, and the microbial population goes up. And so, again, this is not a treatment mechanism we don't think about too much in a pavement system, but they proved quite decisively that there are microbial populations and they are effective at hydrocarbon capture. Really interesting study. These guys are really, I don't know if eccentric is the right word, but they're certainly interesting because they actually came up with microbes in a can that you put on your pavement. You basically seed your pavement with microbes, and they actually really found no difference. The system that they didn't seed still had microbes and increased with the addition of oil, about the same as things they did seed. Again, UNH, as I mentioned, finding about 70% reduction in salt when using permeable pavement systems. Again, of course, it's cold climate. That's very positive because that's the only method for dealing with chlorides and other salts. Let's finish with, I'll tell you a quick story about, since we talked about cleaning pavement in this last couple of minutes, cleaning pavement and infiltration rates. This is a project called, it's Meadow on the Hylobos, and it's a pilot project for Pierce County. And it's a really interesting case study. It's one of the first low impact development residential developments in Washington State. I think actually the first. And I spent 3 years out there monitoring the project. It was primarily flow control, very detailed flow control analysis of this project. If you're interested in that, you can get that research through the Water Environment Research Foundation. There was a pervious concrete shoulder. The road is super elevated and it drains to one side where they had about a 3 or 4 foot wide pervious concrete shoulder. And so I'm out there virtually every day working on the instruments and collecting data and this, that, and the other, watching the whole construction process. And it was so interesting being out there and them, nobody knowing, you know, he's not involved. We don't know who this guy is, another construction guy. We don't even know who he is. And so it was just kind of the fly on the wall. And it was so interesting to watch the workers, for example, doing landscaping and other things. They would wash down the pavement. The home builder was trying to be conscientious and keep the place looking nice. They heard there was something special about the project, but didn't know what it was. And so they'd wash down the pavement. And I could hear the conversations. They're like, wow, this is really cool. We wash down the pavement, and all the water and everything disappears into that concrete. You know, all the dirt and concrete, all the dirt and water, and it just goes away. I'm just thinking, oh, this is perfect. I love it. And then on top of that, the builder, wanting to be conscientious and keep the site looking nice, once a week would have a truck come in and wash all the debris and dirt off of the pavement, off the asphalt, into the pervious concrete. So if I was going to design a pavement clogging test, absolute worst case scenario you could possibly imagine, this would be it. And so fortunately, we had been measuring the infiltration rates on this, and the initial rates, we had about 1,000 centimeters per hour. After all of that activity was down to about, you can see there, about 3.3 centimeters an hour. So now we're getting very, very low. We're getting down to around 1 inch per hour. And they came back in and pressure washed and came back up to 105 centimeters. I like to point this out because I think this is probably the worst case scenario you can imagine for a pavement system and how it might behave over time. And you can bring it back, something as simple as pressure wash. There are other recommendations you see out there, and I guess I would caution you, 50% reduction in infiltration over time is very typical. A number is sort of a projection that you hear. I'd say that would be okay for a clean site. Not a lot of vegetation and debris coming onto the site, that might be appropriate. Otherwise, that's probably optimistic. But again, I mean, you could lose 90% plus and still be at infiltration rates that are adequate. All right. You did it. No small feat. That is a big day, a lot of information. Probably at this time of day, the information is flowing out of your head rather than in. The question is, what about chemical spills? Material handling areas, particularly chemicals in a spill, or a gas. So again, this is one of those really fundamental, how do we manage this stuff questions. In a conventional system, you probably have that stuff going down a drain and into receiving water. Now, we would be in a scenario where we'd see that material going through the pavement and into the subgrade. To qualify that question, though, if you look at the infeasibility criteria for pavement, that's one of the infeasibility criteria. So that's the first consideration. You know, as a jurisdiction, that's one of the criteria. We're going to say, oh, nope, that's not an appropriate place to be using this material. And that could be very much the case. In fact, it probably is. Again, fundamentally, you have two different scenarios there. One, possibly direct release into a receiving water. In this case, release into a subgrade. One important consideration would be what's going on what's in that subgrade.